Hello, this is Jane Talbot and it is day 4 of my Space Odyssey. One of the lines of inquiry that opened up for me yesterday was, what is general relativity? Here goes. Einstein's theory of general relativity is in fact his theory of gravity, and he published this theory in 1915. That is nearly 100 years ago. He expressed his theory using something called field equations, and field equations are a mathematical expression, in this case, of the interaction or interplay between forces, gravity or gravitation, and matter and energy. And so the idea is that there's an interplay between matter and space-time, and the interplay is what we experience as gravity. So for Einstein, gravity fundamentally can change space-time geometry. It curves and bends it, and that's what we experience as gravity. So I'm going to do a little demonstration now. Here is space-time, the field of space-time. So imagine a sheet pulled tight, and when there is no matter in space-time, space-time is completely flat. Introduce some matter and space-time begins to curve or bend. So I'm going to introduce this bulb of garlic, little planet, or a moon. So here we've got space-time, and this isn't too heavy, but it'll probably cause a dent, a curve, or a bend. That is gravity. The interplay between this thing that has mass, this matter, and space-time. Introduce something bigger with greater mass, and in the space-time field here, you might get, can you see? Maybe something with a greater curve or a greater bend. So then, if you have two things in the space-time field, two things with mass, that which has the greater mass will cause a greater curve or bend in space-time, and it's almost like an old mattress where you've got someone heavier and someone lighter, and the person who's lighter will naturally roll towards the thing with the greater mass along the line of curvature. That is gravity. We're on a planet, it has mass, and therefore it affects space-time geometry. It makes it bend and curve, and therefore we experience gravity. That's how we stay on the planet. And we have a moon, and that moon, because we are creating on Earth due to our mass, bends and curves in space-time geometry, the moon will naturally roll towards us. That's gravity, and it's held in orbit by gravity, but it too has mass. And because it has mass, it also exerts an effect on space-time, and it causes it to curve, and we know then it has sufficient pull to pull the tides, and that's how the tides work. That is gravity, and that, I think, is general relativity in under 4 minutes. Space-time tomorrow. Bye.